Today we're covering section 3.4, and this is begins with the topic of transformations of functions. We first want to talk about vertical shifts. And when we talk about vertical shifts, we're looking first of all at the parent function being x squared. So dealing with that, we've got g of x is one of our functions, and it's x squared plus 3. Anytime you add a value to a function, to the parent function, you're going to be moving the graph of the function up. And in this case, it's moving up 3 units. So we're going to consider that function. We know the translation there is it's just going up 3 units. But if we subtract from the parent function, we're going to be moving down. So in this case, we move down 2 units. So we'll get that out of the way here for you. If c is greater than 0 and y equals f of x plus c, this is going to shift the function c units up. If you have f of x minus c, this is going to shift the function c units down. So when we look at this, we've got this function here, and we're given f of x equals x cubed minus 9x. So that is our parent function. And we want to first of all look at g of x. Well, notice that this part right here is the parent function. So we're taking that parent function, f of x, and we're adding 10. So that means we're going to move up 10 units. Then as we look at h of x, notice here again we have the parent function, and we are subtracting 20. So that's going to move the function down 20 units. Now horizontal shifts, let me get those marks out of there. Horizontal shifts, when we move things left and right, we're no longer affecting the whole function or adding something to the entire function or subtracting. We're now going to add to the x value inside the parentheses. Remember that anytime we deal with x and y, anytime we deal with x's, this is moving us left and right because the x-axis goes left and right. So again, if c is positive, adding c to x is going to actually move us to the left c units. So when you affect x, this actually works backwards of what you would think. So in here, when we have x minus c, that's going to move you to the right c units. So we're just going to take that parent function, and it's going to be moving to the left or right that distance. So to look at example 3, we've got f of x equals x squared. To describe the transformations, notice in here we've got x plus 4. That whole quantity is squared, but it's the x that's added to, the 4 is added to the x, that's going to move us to the left 4 units. Over here to the second part, we've got x minus 2, that's going to move us 2 units, and it is in with the x, so that's going to be 2 units to the right. Okay, now here we're given a function f of x equals the square root of x. We are supposed to describe the transformations of g of x, and then we're supposed to sketch the graph. Well, notice right here that we are changing the x value. That is x minus 3, so we're going to move to the right 3 units. Then outside, not affecting the x, is a plus 4, so that's going to move us up 4 units. So each point on this graph is going to move to the right 3 and up 4. So I'm going to pick this point right here, the origin, and I'm going to pick this point right here, and that's going to help us graph this shape. So we're going to move to the right 3, 1, 2, 3, and we're going to move up 4, 1, 2, 3, 4. So this function is actually going to start at the point 3, 4. This point is also going to move to the right 3. 1, 2, 3, and up 4. 1, 2, 3, 4. So it's going to go through there. We also have one other point that's a little bit more difficult to see, but it's the point 1, 1, and that's going to move to the right 3. 1, 2, 3, and up 4. 1, 2, 3, 4. So now knowing we've got these 3 points, we're going to get our shape that's going to look like, whoops, I lost my pen there for a second. It's going to look basically like that. And so what has happened is this whole graph has shifted 3 units to the right and then 4 units up. And you can see that from the picture. The black graph will get moved 3 units to the right and 4 units up. When we talk about reflections, when we take the entire function and make it negative, that's going to reflect the graph over the over the x-axis. Again, here when we look at a negative, that negative is not affecting the x, which means it's affecting the y, and so that's going to change things from top to bottom. That's where the y-axis goes, top and bottom. So that's going to reflect it over the x-axis. When you've got this negative in here affecting the x, that changes things left and right. So whatever is on the left side of the graph will move to the right. Whatever is on the right side of the graph will move to the left. So that's a reflection over the y-axis. So in example 5 here, we're describing the transformations. G of x equals negative x squared. Notice the negative is not squared. Okay? That negative is not squared, so that is not affecting the x, that's affecting the y value. It's going to be a reflection over the y-axis. The x-axis, because it's flipping from top to bottom. Reflection over the x-axis. When we look at the second one, the parent function here is the square root of x. Notice the negative is inside with the x, so that's going to flip it from left to right, which means that one is a reflection over the y-axis. All those x values are changing, so that reflects over the y-axis. Now when we talk about stretching and shrinking, again, we have to think about, is this affecting the x values or is it not affecting the x values? So first of all, we can see this c is not affecting the x values. It's affecting the entire function, which is the y values. So if c is greater than 1, this is a vertical stretch by a factor of c. And that means when we talk about a vertical stretch, we're stretching it from the x-axis. So everything would be c times further from the x-axis. If c is between 0 and 1, this is a vertical shrink by a factor of c. And what happens is everything is now 1 over c times as far from the x-axis. So looking at this one, if we have f of x equals x squared, describe the transformation. For this one, we look at this. 1/3 is less than 1. It's between 0 and 1. So everything will be 1/3 as far from the x-axis. It's a vertical shrink, and it's 1/3 as far from the x-axis. Notice with this one, being that that's a 5, 5 is bigger than 1, that's a vertical stretch, and everything will be 5 times further from the x-axis. In example 7, we're given our parent function, f of x equals x squared, and we want to describe the transformations for this. Now when we describe transformations, we always have to follow order of operations. So notice, first of all, the squared and the x are simply from the original function. So they don't affect the transformations. That just gives you the shape of the graph. The first thing that we have inside the parentheses is this minus 3. So remember, when you take x minus 3, the first thing that happens here is we're going to move 3 units to the right. Okay? The second thing is we have this negative 2 is multiplied by the parentheses. Well, two things happen here. The first one is the negative is a reflection over the x-axis. It's flipping it up and down. The second thing is it's a vertical stretch by a factor of 2. So it's reflected over the axis and it's also stretched out. The last thing that happens is this 1. Notice that is a positive 1, so we can think of it as plus 1, and that's our last step. Third, we're going to move up 1 unit. That is not affecting the x. That just moves the whole graph up 1 unit. When we talk about stretching and shrinking inside with the x, again, when we affect the x, everything works backwards of what we think. So if c is greater than 1, this is now a horizontal shrink. You have to be careful about that by a factor of 1 over c, just like when the shrink occurred for the vertical. But this time, again, it works backwards. So now everything is 1 over c times as far from the y-axis. It's shrunk in left and right. If c is between 0 and 1, it's a horizontal stretch. Okay, again, it's going to work backwards of what you would think by a factor of 1 over c. So when we look at this, we're going to describe the transformations of this one. Now this one, they don't even give us a specific function, but notice here, the 2 is multiplied by x. And since 2 is bigger than 1, this is a horizontal shrink by a factor of 1/2. And it's 1/2, every point on the graph is now half as far from the y-axis. When we look at this second one, point 2, this is the one that might be a little bit trickier. Point 2 is equal to 2/10, which is 1/5. Okay? Now, when we look at 1 over c, this is how we write algebraically the reciprocal of c. So when we look at 1/5 and we see that 1/5 is getting multiplied by x, this is a vertical stretch, and the reciprocal of 1/5 is 5. I'm sorry, it's a horizontal stretch, and the reciprocal of 1/5 is 5, so everything is 5 times further from the y-axis. Another topic when we deal with functions is the topic of even and odd. So here's the deal with even and odd. If we replace the x with a negative x, and that doesn't change the value of the function at all, those two functions are still equal, this is what we call an even function. If you can do that with any positive and negative values and you plug them in and you get the same value, that is an even function. The definition of an odd function is when you replace that x with a negative x, it changes the sign of the original function. So just as an example, if you plug in, for an even function, if you plug in f of -2, that will have to be equal to f of 2. Whereas for an odd function, if you plug in f of -2, it will be the opposite of f of 2. So that's the difference between an even function and an odd function. So let's determine if these functions are even, odd, or neither, because just like numbers, we have even numbers, we have odd numbers, and then we have numbers that are not even or odd. So here's how we do this. We plug in f of -x, which would be -x to the 5th power plus -x. Now remember, our two options are, it's either going to be exactly the same, or it's going to be an opposite. So that's what we want to look for, same or opposite. Well, -x to the 5th power, that's 5 negatives, that's going to be -x to the 5th. And then minus x. So the first thing we check, are these two the same? And the answer is no. So we know that it's not even. Secondly, we want to check, okay, if I factor out a negative, Okay, is this the opposite? So are these opposites? And the answer is yes. So that tells us that since one is x to the fifth plus x, and the other one is the opposite of x to the fifth plus x, this is an odd function. When we look at g of x, again, we plug in g of negative x. That's 2 times negative x minus negative x squared. So this is negative 2x minus x squared, because that'll give us a total of 3 negatives. So again, we check. Are these the same? And again, the answer is no. So then we look, are they opposites? We factor out a negative. So that would give us 2x plus x squared. So are they opposites? And, whoops, I forgot my parentheses. And again, the answer is no, because this one has a positive and this one has a negative. So the answer is they are not opposites. So they're not the same, and they're not opposites. So this one is not even or odd. It's neither. And finally, for h of x. h of negative x is equal to 1 minus negative x to the fourth. Well, negative x to the fourth, when we simplify that, we have a total of 1 negative here and 4 more there. That's still going to be, forget that, 1 minus x to the fourth. And notice now, are these the same? Yes. Since they are the same, that is an even function, and that is the answer for h of x. h of x is an even function. Your assignment for this one, section 3.4, is assignment number 20, and it's listed there, so you can get started on that. And again, you will have time during class to work on some of those.